All right, let's go over your warm-up. Sampling distributions and notation. Have you got this down? So let's talk about this problem here. First, we know that this is a proportion problem. Okay, so we know we have a proportion here because we have 33% of Americans who experience stress. So we are going to describe the distribution for the samples of size 45. So that's your socks, your shape, center, spread, no O. Here we go. Random, independent, and large enough. So for our random, it did not state that they were randomly selected students, so we're going to assume that these 45 students were randomly selected, or assume that these 45 students are representative of all these all American students. Independent, or all these, whoever it is that we're trying to generalize to, like the teacher's class or whatever, all these kinds of students. Independent, N is less than 10% of the population, so 45 is less than 10% of all such students. Large enough is tricky because it depends. Is it a mean problem or a proportion problem? So if it's a proportion problem, then you need to do N times P, which that equals 14.85, and that is greater than or equal to 10. N times 1 minus P, which is 30.15, and that is greater than or equal to 10. So approximately normal model applies. Now the center is the mean of, so where all the P hats should be centered is 0.33. And then the spread. Okay, so let me, I don't have anything extra on here with the exception of, let me just go ahead and take away the part that's extra. I don't have to have written this formula here, or that equals P, okay? And I don't have to have written this formula here. But all the rest of it, you should show the numbers that go into that. Okay, next. So, guys, what's happening is this. You have a distribution where you have a bunch. There's a sample of 45. Here's a sample of 45. You have all these samples of 45 students, okay? And they should be centered around 0.33 experiencing stress. 33% of a sample is experiencing stress. Do not come over here and say the mean is 14 point whatever. Do not call the mean 14.85 because this is a proportion problem. It is 33% of a sample. So when it says what's the probability that no more than 12 students are experiencing stress, well, that's telling you how to get your p hat. That's 12 out of the sample of 45, so the p hat you're interested in is that 0.27. All right. And then we know from up above our standard deviation. So we're seeing how far away is this 0.27, okay? And what's the probability that no more than 12? So I want to know this probability down here. So I'm going to get my z-score for that p hat. P hat minus the mean over the standard deviation of p hats is negative 0.86, so that's the z-score. So I'm going to take that z-score and I'm going to norm CDF the lower part. So 19.49% of samples will show that no more than 12 out of the 45 students say they frequently experience stress. Okay. Now, if 20 students in the class say that they frequently experience stress, should we be surprised? Is this something we need to be worried about? Does this mean, whoa, this 30.33 is maybe actually higher for this particular type of students or this class? Okay, so let's talk. So this 20 students is, we want to know, how does this sample p hat of 20 over 45 compare to the norm that it's supposed to be? So you could do a couple of ways. I have it shown both ways here. You can either see How far away would that be? Would 20 out of 45, which is 44%, would 0.44 be unusual? Or could that be sampling variability? So I can see that it ends up being 1.57 standard deviations above the mean. So I'm not too worried about that, okay? I would not consider that 12 students who experience stress unusual because it is only 1.5 standard deviations above the mean, and that can be due to sampling variability. Okay, now you might have also done it this way. You might have decided, I want to find where the outlier fence is. And so if you decided to find where the outlier fence is, then you did it like this, 0.33 plus 2 of the standard deviations, and that's 0.47. And so then once again, you had to say, okay, this 20 out of 45, which is 0.44, is less than, it's inside the fence, so it's not an outlier. So that's not surprising, okay? You might have also, if you were going in that direction of the number of students, then this is the very last option. I mean, this might have gotten you marked partial credit because you're doing this in terms of the number of students, but this problem is in terms of the percentage of students. So you need to, that's why it needed to stay in terms of percentages the whole way through. Okay, some people will ask me, well, why couldn't I just do this as a number of items? Well, because, you know, for one, this standard deviation is standard deviation of p hats, not standard deviation of number of students. And that's typically where my students have problems. Okay, they turn that in, or they have problems with that standard deviation component messing them up. All right, let's move on. Ooh, this is interesting. I got this data. This is real data. And so whenever on the next page you see something that's like crazy, yeah, it's for real. So we'll talk about what that means. Here we go. The average composite ACT score of Texan students is 20.2 with a standard deviation of 1.05 points. Now, in a random sample of 25 Aledo High School students who took the ACT in 2018, the average was 24 points. Standardized test scores such as SAT and ACT scores are distributed normally. So that is what is meant by that term standardized. All right, so let's go on. So the first thing says describe the distribution for samples of size 25. So I'm going to go through my random. So it's stated that it was randomly selected sample of 25 Aledo students. Okay, independent, 25 is less than 10% of all Aledo High School students who have taken the ACT. Large enough is tricky because it all depends. Mean or proportion, mean is 30, and that's when I get a little worried because 25 is not greater than 30. So I get a little flinchy right there for a second and worry. Okay, but remember what I told you way back here, and I tried to stress that with you today. Small sample, we're on this row right here if you have a small sample. But right here, it's okay because we were told the population of all students is normally distributed. So this being told to us means even though our sample size is 25 and not 30, we're still okay. All right, so that saved us. So let's see if we can't get back there. And there we go. So now then our mean. Okay, so I had several questions asking me, how do I know which is the population mean and which is the sample one? Okay, which is which? So I think the best way to explain it is think what of these two things we're talking the average for Texas high school students and the average for 25 Aledo students. Okay, so what does that mean? What would you consider the population? What would you consider the sample mean? So we want to know what are these two situations. Well, I think it's understandable that this Texas student average is what is being considered the population mean of 20.2. Okay? And I think it also makes sense that it's a sample of 25 Aledo High School students, and that sample averages 24, so the X bar is 24. Now, you may still be like, okay, that doesn't tell me anything. Okay, so do you know that what's happening is, see, all of our, so that this is saying if Aledo High School has the same average ACT as Texas students, as all Texas students, then our samples should be centered in the same area, all of our samples of 25 students, and I get an average for each random sample of 25 students, okay, that have taken it. So then that should be centered at the same as the Texas, so that would be centered at 20.2. Hence, that's the population mean where the sampling distribution is centered. Now, it will have a smaller spread, that standard deviation of the X bars. You don't have to write this formula here, but you have 1.05 divided by the square root of 25. Okay. So some of this might have kind of, you might have put that down, and then when you get over here to the next page, you're like, what the heck is happening? Okay. So here's what the deal is. So here's the population average, the population standard deviation. So I could ask what proportion of Texas students went higher than such and such, okay? Anyway, we took a sample from Aledo, and they averaged 24. Here's where they should be centered with that standard deviation. Holy moly. This, are we not freaking out? Do we not think we did something wrong? I was like, what the heck? Here's what this says. What this is indicating to us is there's pretty much no freaking way, 0% chance that the average for Aledo's ACT scores is the same as 20.2. See, if Aledo's are the same, then Aledo's samples will be centered at 20.2. And they weren't even close. They were like, okay, like way over here. Okay, so that says Aledo's students have a much higher, I don't know how much, but they have a higher average, not the same as the state of Texas. Now, I'm not going to say that we're all high and mighty and wonderful and perfect and all that kind of stuff. We are, but I truly think that sample from 25 Aledo High School students is a biased sample. I don't think it's a representative of all Aledo High School seniors. How many of our students take the SAT or the ACT? A lot of them take the SAT, not too many take the ACT. I think only those that take the ACT are those top tier students who are trying to, getting those scores, because a lot of northern schools actually do the ACT more than the SAT. So honestly, I don't think this is for real saying that we are that much better than the state of Texas on our standardized tests. I think we're better, but not necessarily that much better, because it was a matter of the bias. It was a bias which had our whole shift up anyway. Okay, so there is what's going on there. Now, let's just check the probability notation. Make sure you understood and got all of that correct. Here they are. Sample proportion, population standard deviation. That's the population proportion. This is where the average of all of these, the sample means, would be found. Okay, here's how varied all of those X bars, those sample means, would be. Here's where the center of all the P hats, the sample proportions, should be. And here's your sample size N. Now here is your samples mean. So whatever our samples mean for the ACT score or whatever. Here's the population mean. And here is one individual piece of data. So the data from the population is an X. And that standard deviation of the p-hats. And there it is. All right. So tomorrow, before the quiz, I will not be going over as in depth as this video here. You are welcome to ask me questions. You can message me or you can ask me questions at the beginning of the class. I just won't be able to go spend as much time on this because I want to make sure I give you enough time during class to be thorough on all of your writings and to fully understand what's happening so that you can do strong explanations and say what's happening and good conditions and assumptions. So you are supporting the fact that you are using normal model math to make these inferences. All right. So good luck to you on your sampling distributions quiz.